Welcome to the deep dive. Okay, so today, forget your usual software automation. We're diving into something new. Agents.
Right. These are a new kind of system, really, powered by LLMs.
Exactly. Think of them as, I don't know, intelligent helpers. Systems that can handle really complex multi-step tasks all on their own. We've seen LLMs get amazing at reasoning, handling different kinds of data, using tools. Agents feel like the next big step.
That's a great way to put it, yeah. At their core, agents are built to basically run whole workflows for a user autonomously.
And a workflow is just what exactly? Like a series of steps?
Pretty much. A sequence of actions to get something done could be customer service, making reservations, changing kind, generating reports, you name it. But the key thing, the revolutionary part, is that the LLM isn't just processing the info. It's actually directing the workflow. It's in control.
Okay, so definitely not just chatbots with a bit more power. We're talking something different here. What really defines an agent then? What makes it an agent?
Good question. There are two main things, really. First, the agent uses its LLM brain, if you will, to manage the whole workflow. It decides the next step. It figures out when the job's actually finished.
Ah.
It can even, spot problems and try to fix them, or just stop if things go wrong, proactively.
Right, so it's got some agency, literally.
Yeah.
And the second thing?
Second, it has access to tools. Think of these as its hands and ears, ways to interact with other systems, grab information it needs, or take actions out in the world. And it dynamically picks the right tool for the job, but always within, the boundaries you set.
Got it. So for anyone listening who wants to get up to speed on this pretty cutting-edge stuff quickly, this is your fast track. We're going to break down, when you should even think about building an agent.
Yeah, it's not always the answer.
How they're actually put together, maybe touch on some clever design ideas. The mission today is really to give you that essential grasp of these, pretty sophisticated AI systems.
Precisely. We're laying the groundwork so you can understand how these intelligent systems are being built and, frankly, why there's so much buzz around them right now.
Okay, let's get into it then. When should someone actually build an agent? Because it feels like overkill for some things, right?
You're absolutely right. It's not a one-size-fits-all solution. Agents really shine where the old ways, the traditional rigid rule-based automation systems, where they struggle.
Can you give an example?
Sure. Think about analyzing payment fraud. A standard system. It probably just follows a strict checklist. If this, then that.
Right. Very deterministic.
Exactly. But an LLM agent, it can act more like a seasoned investigator. It looks at the context, it understands subtle clues, maybe spots weird patterns that a simple rule would just completely miss. It's a different way of thinking about the problem.
That's a fantastic analogy.
Yeah.
So where do those traditional systems usually fall short? What are the signs that an agent might be the better path?
I'd say there are three main characteristics of workflows where agents really add value. First one, complex decision-making. Okay.
If your process needs nuanced judgment calls, handling lots of exceptions, making decisions based on context, that's always changing. Think about approving a really tricky refund request, maybe.
Yeah.
That's agent territory.
Complex decisions, nuanced judgment. Got it. What's number two?
Second is when you have rules that are just a nightmare to maintain. These incredibly complex, tangled rule sets where every time you need to update something, it's costly, or you risk breaking something else.
Yeah, like compliance checks or something.
Exactly. Like vendor security reviews, they can get incredibly complicated. An agent can often handle that complexity more flexibly.
Okay, complex decisions, messy rules. Makes sense. What's the third one?
Third is when your workflow relies heavily on unstructured data. Stuff that isn't neatly organized in a database.
Like emails, documents, conversations.
Precisely. If you need to interpret natural language, pull meaning out of documents, have actual conversations, maybe processing home insurance claims that come in all sorts of formats, agents are really, really good at that. So the takeaway here is, before jumping on the agent bandwagon for every little thing, really look at your workflow. Does it have that complex decision-making? Those tangled rules? Does it swim in unstructured data?
Exactly. Validate it first.
Because otherwise, maybe a simpler deterministic approach is actually fine. Maybe even better.
Absolutely. Choose the right tool for the job. Make sure an agent is genuinely the most effective solution for your specific problem.
Okay, right. Let's assume we've done that. We decided, yes, an agent makes sense here. What are the basic building blocks? What goes into making one?
Fundamentally, every agent is built on three core pillars. First, the model. That's the LLM, the engine doing the thinking, the reasoning, the decision-making.
Right.
Kind of, yeah. Second, the tools. These are the external functions, APIs, ways for the agent to actually do things or get information from the outside world.
The hands and ears.
Exactly. And third, the instructions. These are the explicit guidelines, the rules of engagement, the guardrails that define how the agent should act, what its goals are, what it shouldn't do.
The operating manual, maybe.
That's a good way to think about it. Brain, hand sears, and a manual. Model, tools, instructions.
You mentioned the OpenAI agents SDK before.
Yeah.
How does something like that fit into this picture? Does it just package these things up?
Yeah, essentially. An SDK like that gives you a structured framework to bring these three components, model, tools, instructions, together in your code. You define your agent, you write its instructions in plain English, you tell it which tools it can use. It just helps organize everything, makes managing those interactions easier.
Okay, let's dig into each of those pillars a bit more. Starting with the model. There are so many LLMs out there now.
Yeah.
How do you choose?
It's a key decision, and yeah, it can feel overwhelming. The main trade-offs are usually around capability, how complex a task can it handle, latency, so how fast does it respond, and of course cost.
Right, the bigger, smarter models often cost more per use.
Exactly. And what's interesting is you don't necessarily have to stick with just one model for an entire agent workflow.
Oh, how does that work?
Well, you might use a really powerful, capable model for the parts of the task that need deep reasoning or complex decision-making. But for simpler steps, maybe just retrieving some basic info or formatting output, a smaller, faster, cheaper model might be perfectly adequate. You can mix and match.
That's smart, like using the right size hammer for the nail. So how do you figure out that mix? What's a good process?
A really practical strategy is to start by prototyping with the most capable model you can get your hands on for all the steps.
Go big first.
Yeah. Establish a performance baseline. See what's possible when the model is really good. Then, once you have that working and you have some way to evaluate performance, like accuracy metrics,
Okay.
then you can start experimenting. Swap in smaller, faster models for specific, less critical parts of the workflow. See if performance holds up.
Yeah.
You optimize for cost and speed after you've nailed the accuracy with the best model.
Aim high, get it working, then optimize down. I like that. Okay, pillar number 2, tools. What gives the agent its hands and ears?
Tools are what let the agent break out of its own box, basically. They connect it to the outside world, other apps, databases, APIs. That's how it gets context or takes action.
So mostly interacting via APIs.
Mostly, yes. But what's really fascinating is that for older systems, legacy software that doesn't have nice modern APIs, agents can sometimes use these things called computer use models.
Computer use models, what are those? Like screen scraping?
Sorta, but more sophisticated. They're models trained to actually look at a graphical user interface, a screen, understand what's there, like buttons, fields, menus, and then interact with it. Click here, type this there, navigate around, almost like a person would.
Whoa, okay, so you could potentially automate interactions with really old software that way.
Potentially, yeah. It opens up a lot of possibilities for integrating with existing systems that you maybe thought were impossible to automate this way.
That's huge. Now, you also mentioned standardized definitions for tools being important. Why is that?
Standardization is key for making this scalable and maintainable. If tools have clear, consistent definitions, what inputs they take, what outputs they produce, what they actually do, then it becomes much easier for different agents to use the same tool. It helps with discovery, reuse. Imagine building a library of reliable tools your different agents can draw from.
Like building blocks.
Yeah.
Makes sense. And you break tools down into categories.
Yeah, broadly 3 types. First, data tools. These are for fetching information, querying a database, reading a PDF, searching the web, checking a knowledge base, getting context.
Okay.
Second, action tools. These let the agent actually do something. Send an email, update a CRM record, create a support ticket, maybe execute some code.
Right, affecting the outside world.
Exactly. And the third category is a bit more meta. Orchestration tools. This is where one agent can actually call another agent as if it were a tool. We'll probably talk more about that when we get to multi-agent systems.
Intriguing. Okay, so could you give just a quick, simple example, like equipping an agent with a couple of tools?
Sure. Let's say you have a simple research agent. You might give it a web search tool that takes a query and returns search results. And maybe a save to file tool that takes some text content and a file name and saves it. The agent's instructions would then tell it, okay, search for this topic, find the top 3 results, summarize them, and then save the summary to researchnotes.txt using the save tool.
Got it. Very clear. All right, that brings us to the third pillar. Instructions. You said these are critical.
Absolutely critical.
Hmm.
You can have the best model and the coolest tools, but if the instructions are vague, ambiguous, or incomplete, the agent is going to flounder. High-quality instructions are probably the most important factor for reliable agent performance.
It's like giving someone a map versus just pointing vaguely and saying, go west.
Exactly. Good instructions reduce that ambiguity, guide the decision-making, and ultimately lead to fewer errors and more successful workflow completion.
So what makes for good instructions? Any best practices?
Definitely. One really effective approach is to look at your existing documentation. Things like standard operating procedures, SOPs, customer support scripts, internal policies.
Stuff you already have written down.
Right. Often the core logic you need is already in there. You just need to adapt it into clear step-by-step routines that an LLM can easily follow. For instance, take a troubleshooting guide. Break that down into numbered steps for the agent.
That makes a lot of sense. Leverage what you've got. What else?
Explicitly prompt the agent to break down big tasks. Don't just say, plan a trip. Say, first, ask the user for their destination and dates. Second, search for flights using the flight tool. Make the steps granular.
Smaller, clearer steps.
Okay. And for each step, define a really clear action or expected outcome. Be precise. Instead of check customer status, say, use the CRM tool to retrieve the customer's account tier and loyalty points. Precision matters.
Minimizes wiggle room for the LLM.
Exactly. And crucially, think about edge cases. What happens if the tool fails? What if the user gives an unexpected answer? Good instructions anticipate these common problems and provide guidance of maybe conditional steps, fallback actions, ways to ask for clarification.
Handling the what-ifs. Got
Right.
it. And you mentioned earlier that some advanced models could even help write these instructions.
Yes, that's an exciting development. You can potentially feed an existing document, like an SOP, into a powerful LLM and prompt it specifically to extract the key steps, decisions, actions, and format them as a structured routine for another agent to follow.
Like, read this PDF and turn it into a numbered list of instructions for a customer service agent.
Basically, yeah. With the right prompting, it can do a surprisingly good job, which can be a massive time saver when you're building these routines.
Wow, okay. That's pretty powerful. So we've got the model, the
Mhm.
tools, the instructions, the building blocks. Now, how do we actually get them working together to run a whole workflow? That's orchestration, right?
Exactly. Orchestration is all about coordinating these pieces to execute those multi-step tasks effectively. And while you might dream of the super agent handling everything flawlessly,
Haha, yeah, the ultimate goal, maybe.
the reality is it's often much better to start simpler. Build up complexity incrementally. Don't try to boil the ocean on day one.
Wise advice for any project, really.
Yeah.
So what are the main ways to orchestrate agents?
Broadly, there are two main camps. First, single agent systems. Here you have one LLM armed with its tools and instructions running the whole show in a kind of loop.
Okay, one agent does it all.
Right. The second camp is multi-agent systems. In this case, the workflow is actually broken down and distributed across a team of agents that coordinate with each other.
Like a team of specialists. Let's tackle the single agent approach first. How does that loop work?
Think of it as a run. The agent starts, it looks at the situation, its inputs, its instructions, it thinks the LLM processes, and then it acts. Maybe calls a tool, maybe generates a response. This loop continues until some exit condition is met.
What kind of exit conditions?
Could be several things. Maybe it successfully calls a tool and gets the info it needs to finish. Maybe it produces the final output the user asked for. Maybe it hits an error it can't recover from. Or, importantly, maybe it hits a preset limit on how many turns or steps it can take. That's a safety measure to prevent infinite loops.
Right, you need a way to stop it if it gets stuck.
Yeah.
You mentioned runner.run in the SDK context before. Is that basically kicking off this loop?
Yeah, in that specific SDK, calling something like runner.run initiates that cycle. The agent observes, thinks, acts, observes the result, thinks again, acts again, rinse and repeat until one of those exit conditions triggers and the run ends.
Okay, so it's a cycle of perception, thought, action. But even within a single agent, workflows can get pretty complex. How do you manage that without immediately jumping to multiple agents?
Great question. A really useful technique here is using prompt templates with variables. Instead of writing dozens of unique, hyper-specific prompts for every little scenario.
It sounds like a maintenance nightmare.
Exactly. You create a more general base prompt, but you include placeholders, like variables. Then, before you run the prompt, You dynamically fill in those variables with the specific details for the current situation, customer name, order ID, the specific question asked, whatever.
So the core instruction is the same, but it gets customized on the fly.
Precisely. It makes your prompts way more flexible, much easier to manage, and simpler to test and evaluate. You could have one template for a support interaction that adapts based on whether it's a billing question or a technical issue just by changing the variable inputs.
That's a smart way to handle variations. But surely there's a point where even that gets too messy, and you do need multiple agents. When is that?
Yeah, there is a tipping point. Our general advice is always try to push the single agent as far as you reasonably can first. Adding more agents means adding coordination overhead, which is its own complexity. But there are a couple of signs. One is if your prompt logic gets really convoluted, just tons of if this, then that, unless this other thing conditions nested inside each other. If the prompt template itself becomes incredibly hard to read and maintain, maybe it's time to split the logic.
Okay, sheer logical complexity. What else?
The other big one is what we sometimes call tool overload. And this isn't strictly about the number of tools, though that can be a factor if you have, say, dozens. It's more about the similarity or overlap between tools.
So the agent gets confused about which tool to use for what.
Exactly. If you have several tools that do slightly different versions of the same thing or their descriptions aren't clear enough, the LLM might struggle to pick the right one reliably, even with fewer than, say, 10 tools. But before you immediately split into multiple agents just because of tool confusion,
Yeah.
always try improving the tools first.
Yeah.
Better names, clear descriptions, maybe more distinct parameters. Sometimes just cleaning up the tools solves the problem without needing more agents.
Good point. Optimize the single agent first. Okay, but let's say we've done that and we still feel a multi-agent system is the right move. What are the common ways to structure those? What are the patterns?
We generally see two main architectural patterns emerge for multi-agent systems. Think of them like organizing a team.
All right.
Pattern one is the manager pattern. Here, you have a central manager agent that basically delegates tasks to other, more specialized agents. It calls these specialist agents like they were tools.
Like a boss handing out assignments.
Pretty much. The manager stays in control, coordinates the work, and usually synthesizes the final result. The second pattern is the decentralized pattern. Here you have agents that are more like peers, and they hand off the work directly to each other based on who's best suited for the next step.
More like passing a file along an assembly line of experts.
That's a good analogy, yeah. Let's unpack the manager pattern first.
Okay, the boss agent. How does that work practically?
Imagine a task with distinct stages or needing different types of expertise. Let's say translating a document into multiple languages. The user asks the manager agent, translate this into French, Spanish, and Italian.
Right.
The manager agent receives this. It doesn't do the translation itself. Instead, it recognizes it needs French, Spanish, and Italian translations. It then calls specialized tool agents, a French translator agent, a Spanish translator agent, and Italian translator agent. It sends the document to each.
Huh.
Each specialist agent does its translation and sends the result back to the manager. The manager then gathers all three translations and presents the final combined result to the user. It orchestrated the whole thing, but relied on specialists for the actual work.
So the manager keeps the big picture view and pulls the strings.
Exactly. It's great when you need that central control point, maybe to ensure consistency or combine results from different domains.
Now, you touched on different ways to define these systems, declarative versus code first. What's the difference there?
Some frameworks let you define these multi-agent interactions visually, maybe dragging boxes and arrows or using configuration files. That's declarative, you declare the structure up front. Can be nice and visual for simpler setups.
Wow.
But as things get more complex, dynamic, with lots of conditional logic, that declarative approach can become rigid or cumbersome. The alternative, which you see in tools like the Agents SDK, is more code first. You define the logic of how agents interact using actual programming code.
So you get more flexibility.
Yeah, you get the full power of a programming language to handle complex coordination, conditional handoffs, error handling between agents. It tends to scale better for really intricate orchestrations.
Makes sense. Okay, now the other pattern, decentralized.
Yeah.
How does that peer-to-peer handoff work?
Right. So no central boss here. Instead, agents have the ability to pass the entire control of the workflow over to another agent. Think of it as a one-way transfer.
So once it's handed off, the first agent is done.
Typically, yes. Agent A does its part, realizes Agent B is needed for the next phase, and uses a special handoff tool to pass the conversation state, context, everything over to Agent B. Agent B then picks it up and continues the interaction with the user.
Where would you use that kind of pattern?
It's really effective for things like conversation triage. Imagine a customer contacting support. The first agent, a triage agent, figures out what the customer needs. Is it tech support, a sales question, or an order issue?
Okay.
Based on the need, the triage agent hands the conversation off to the appropriate specialist, the tech support agent, the sales agent, or the order management agent. That specialist then takes full ownership and resolves the issue. You don't need the triage agent involved anymore.
Ah, I see. So it's great when different specialists can fully handle distinct parts of a process independently.
Exactly. When you don't need that central synthesis or ongoing coordination by a single manager, the decentralized handoff can be very clean and efficient.
Okay, fascinating. Two distinct ways to organize agent teams. Now, a really crucial topic whenever you have AI systems acting autonomously. Safety. Guardrails.
Absolutely critical, non-negotiable, really. If
Yeah.
these agents are interacting with systems, data, users, you need robust guardrails. They're there to manage risks, data privacy, system integrity, reputational damage, you name it.
And it's not just one simple check, right? You mentioned a layered approach.
Yes, the best practice is definitely a layered defense. Think of it like security for a building. You don't rely on just one lock. You have multiple layers, each specialized for a different kind of threat.
Can you walk through that? Like what happens when a user sends a message?
Okay, so user input comes in. First, maybe it hits an LLM-based guardrail. This could be a relevance classifier. Is this request actually related to what the agent is supposed to do? Or is it asking about the weather when it's a booking agent?
Okay, topic check.
And maybe another LLM check for safety. Is this a prompt injection attempt? Someone trying to jailbreak the agent or get it to reveal its instructions?
Right, malicious intent detection.
Then it might go through more traditional rules-based checks. Does it contain blacklisted words? Is it too long? Does it match a pattern known to be problematic? Maybe a regex filter.
Deterministic checks.
Exactly. And then maybe it also goes through a dedicated moderation API, like OpenAI's, which is specifically trained to catch things like hate speech, harassment, self-harm content.
Socialized content filtering.
Right. And if any of these layers flags a problem, you have a predefined action. Block the request, send a generic refusal, maybe flag for human review. It's about multiple checks catching different things.
That multi-layer approach makes a lot of sense. So what are the key types of guardrails people should be thinking about building?
We touched on a few. There's the relevance classifier, stay on topic. The safety classifier, detect jailbreaks, injections. A PII filter is crucial, preventing the agent from accidentally revealing or even requesting unnecessary personal info. Moderation for harmful content. Then there are tool safeguards. Maybe you rate your tools based on risk. A read-only database query is low risk. Deleting user data, high risk. High-risk tools might require extra checks or even human approval before the agent can use them.
Smart. Differentiating risk.
You also have those rules-based protections, block lists, length limits, etc. And, importantly, output validation. Check what the agent is about to say before it says it. Does it align with brand voice? Is it factually grounded? Is it safe?
A final check before it goes out. That's a lot of potential guardrails.
Yeah.
What's a sensible way to approach building them? You can't build everything on day one.
No, definitely not. A good heuristic is start with the essentials. Focus heavily on privacy, like PII filtering, and core safety, blocking harmful content, basic injection defense, right from the beginning.
Table stakes.
Exactly. Then, as you deploy and monitor the agent in the real world, see what issues actually come up. Are users constantly trying to take it off topic? Add a stronger relevance guardrail. Are certain tool uses causing problems? Add specific safeguards for those tools. Iterate based on observed behavior.
Learn and adapt.
Right, and always try to balance security with user experience. Overly aggressive guardrails can make the agent feel useless or frustrating. It's a tuning process.
You gave an example of the SDK notes about a churn detection tripwire. Can you explain how that works as a guardrail?
Yeah, that's an interesting example of a more proactive semantic guardrail. So imagine you have your main customer service agent. You also create a separate specialized churn detection model or agent.
Okay, one focused just on identifying unhappy customers.
Right. The churn detection tripwire is set up as an input guardrail on the main agent. When a user message comes in, it also gets sent, maybe in parallel, to the churn detection agent. If that churn agent analyzes the message and says, hey, this user sounds really likely to cancel their subscription, it signals the tripwire. This triggers a specific exception, like guardrail tripwire triggered, in the main agent's flow.
So the main agent is interrupted.
Potentially, yeah. The main agent might be trying to answer the user's question, but this exception gets raised. You can then catch that exception and implement specific logic like immediately route this user to a human retention specialist instead of continuing the automated flow.
Wow, so it's using another AI to proactively flag a risk and change the main agent's behavior?
Exactly. It shows how guardrails can be quite sophisticated. It also touches on this idea of optimistic execution the main agent tries to proceed, but these checks are happening, ready to intervene if needed.
Very cool. Okay, one last crucial point on safety. Human intervention. You stressed planning for it. Why is that so important, especially early on?
Because no agent is perfect, especially when first deployed. There will be situations it can't handle, edge cases you didn't anticipate, or just failures. Having a plan for a human to step in is vital.
It's a safety net.
It's a safety net, absolutely, but it's also a learning opportunity. When a human has to intervene, you get valuable data about where the agent is weak, what needs improvement. Early on, this human-in-the-loop feedback is crucial for making the agent better and safer without just letting it fail silently or frustrate users.
So what are the common triggers? When should an agent ideally hand off to a human?
Two main categories. First, hitting failure thresholds. If the agent tries something, fails, tries again, fails again. Maybe after 2 or 3 failed attempts to understand the user or complete a task, it should automatically escalate to a human. Don't let it just keep floundering.
Makes sense. Stop the loop with the second category.
High-risk actions. Anything sensitive, irreversible, or with significant financial or other consequences. Canceling an account, processing a large refund, changing critical security settings.
Things you don't want the AI doing wrong.
Exactly. At least initially, or maybe always depending on the risk, these actions should probably require human review and approval before the agent executes them. Build in those checkpoints.
Prudent safeguards. Okay, this has been incredibly insightful, a real deep dive into agents. If we were to sum up the key takeaways for listeners, what should they remember?
I think the big picture is that agents are a major step up in automation. They bring intelligence and autonomy to complex workflows. Key points. Remember, they're best suited for those workflows with tricky decisions, messy rules, or lots of unstructured data.
Right, know when to use them.
Know the core components, the model, brain, the tools, handseers, and the instructions rulebook. Understand the orchestration options. Start simple with single agents, use prompt templates, and only move to multi-agent manager or decentralized patterns when complexity genuinely demands it.
Yeah.
And crucially, build in robust, layered guardrails from the start, focusing on safety and privacy, and always plan for human intervention as both a safety net and a learning mechanism.
Excellent summary. And for everyone listening, whether you're deep in the tech trenches or just trying to understand where AI is heading, hopefully this gives you that solid foundation on what agents are and why they're becoming so important.
Absolutely. It's about understanding the shift towards systems that don't just process data, but can actually reason, plan, and act to achieve goals across multiple steps. It's a powerful concept.
It really is. So maybe a final thought to leave folks with. As you go about your week, look at the complex processes or the rule-heavy workflows around you. Could any of them be transformed by this kind of agent technology? Definitely something to think about and a space worth watching. Thanks for joining us on The Deep Dive.